Hello again, this is the course of data structure and algorithms, and for this video we are going to learn about the code on BFS. So you already learned about two algorithms for the graph, which is about finding the best path. Okay, so we learn about the DFS depth first search, and the other we learn about the BFS breadth first search. So I would like to return back to the graph example. So if you still remember, in the previous video, I explained about the graph simple example for the network transportation in Korea. Yeah. So we have this kind of graph, and yeah, I also give you the example from the book, data structure and algorithm, like this graph. And yeah, this graph is also available in the code. So I would like to review a little bit for the example and how can we apply with the BFS, and then yeah, how can we compare the performance of BFS and DFS. So I will go to the Jupyter notebook. For this Jupyter notebook, I have updated the code. Okay? Before you run the BFS, you can run from the first part, which is about the graph. Okay? So we already learned about this graph, and then we know about the edges, get edges, degree, incident edges, insert vertex, insert edge. Okay? And then for this, we have the function to add the graph using the add list structure. Okay, so you already learned about how to deal with graph. There are three data structures. The first is using the adjacency list, and the other is using the add list, and the last one we can use the matrix. But for this example, I would like to show you about the add list. So if you have any other idea about the adjacency list, that's fine. Okay? Or if you have the idea about the matrix, that's also fine. Okay, because I think all of them are similar. But if you use matrix, of course, the time performance is slightly higher than the edge list, and the matrix is also slightly higher than the adjacency list. So yeah, I'm using the edge list in order to reduce the time performance. However, you can check if you want to use the matrix, you can figure out later. So for this one, I'm just running the edge list. And as I mentioned to you, we have the graph, like simple example graph. Yeah, we use the ads information like Seoul, Daejeon, Daejeon, Busan, Busan, Daejeon, and so on. And then we make it as a graph. And the other example, we use the figure 14.3. So it is the network transportation, like the airport in US. And information is related with the yeah, route that is available between the airports. So we also make the graph from this edge list. So let's say I'm making a graph Korea, okay, with this simple example. This is the simple example, and yeah, I'm making the okay. This is on the dictionary. So I'm yeah. Last time we already learned this one. Let me skip this one and let me just run this code. Okay, you already learned about this information. And then if I make a graph with this 14.3, okay, so you can get this information from the graph. And yeah, this is the example from the book, figure 14.14. And yeah, you can put the information like the um, the number or the mileage between the airport. Okay. So you can put this 337 as the distance from the San Francisco to Los Angeles and so on. Okay, and I'm making a graph 2 for this one, and you can check this information. So last time we learned about the depth first search. Okay, so this is the code that we can learn using the depth first search. this is the code given by the book Data Structure and Algorithms, and so I just run this one, and then you can get the DFS complete. Okay, so the DFS complete is from the function given by this code, and we are making the depth per search using the Graph Korea example. So if you run this, you can get the idea about the node, which is Suwon, and then you can have the possible link to the other cities like Seoul. We have the Suwon and to Seoul, and then if you are starting from Daejeon, then there will be a kind of node to Seoul, and you can go back to Daejeon, and so on. Okay, so using this DFS, after you find uh, the DFS, you can check the tree. Okay, you can check the forest that is available from the algorithm. You can also use the graph one. The graph one, yeah, you can check from the figure 14-3 from the book. So this is the result. If you use the graph one and you use the graph two, you can also check the result with this information. So this information is about the distance between the airport. Okay, so we just want to check the number of the items that is from the incoming edges. Okay. Now about the breadth first search, okay, because we want to compare. Okay, we want to check if the depth first search is better than breadth first search. If you check on the big O notation, it seems they are the same. But of course, you need to check from the time performance. Even though it has a slightly different time performance, it's a good practice for you to know, well, how can you plot the time performance, and then later on the number of data will affect the time performance as well. So let's do with the breadth first search. This is the code that I took from the book as well. Okay, so this is the BFS. If you know, in the code is a little bit different with your understanding with the algorithm itself, but you can check again the similar things from the DFS. It is about how can we discover the node. So once the node has been discovered, then we want to check the other node, and then we want to check the other edges. But of course, the way to check the node and edges are a bit different with the FS. However, you can check on the code level, like this one from the BFS. It has only how can we figure out the forest, and how can we figure out about the incident edges, and then if we find the opposite, whether it is discovered or not, then you can go to the next level. So this code indicates the process that we already learned on the previous video. And let's suppose we are making the BFS information. So after you get the tree, after you get all the connected nodes using the breadth first search algorithm, so you can plot how can the node, how can you go to other city from one city. Okay, so this is the example. If you are using the incoming nodes, so you can get this information. The same with the other graph. Okay, you have the graph one, for example. So in the graph one, you can also plot the incoming items. In this case, this is the airport information that you already use from the figure 14-3. And then the graph 2 is also another example from the book, which is related with the airport in the US, but it contains the mileage. Yeah, now we are not considering the mileage for the for this kind of graph, But later on, if you want to find the shortest path problem, we might need this kind of information. So I will keep this information for the next example. Now, for this video, I would like to explain how can we do the time performance. Okay, what is the time performance? When you do the time performance, it means you want to know if the time increased by the number of data. Okay, so you have very small data like this one. For example, in the graph Korea, you have only 1, 2, 3, 4, 5. You have only 5 nodes. And if you do with the time performance, it might be very small. Okay, the time performance may be less than 0.0000001 second. Okay, so it's very fast. So how can you prove that your algorithm is good? How can you prove whether your algorithm is good when the number of data is very big? Okay, as I explained to you, the big data is one of the concern, because nowadays data are available everywhere, and when you check with your algorithm, it means you need to know that your algorithm fits with big data. So in order to check your algorithm, maybe you have difficulties to find the good data, and you may say that, yeah, I have very limited data, then how can I do the runtime performance? In that case, I would like to suggest you to use the random generator. Okay, I don't want to discuss the theoretical behind the random generator, but I just want to encourage you to use any tools to generate the data randomly. Okay? So in this example, I would like to give you one example to create a graph randomly. It means, yeah, I don't care about the connection, about the nodes, but I just do care about the number of data. And the number of data should be high and it should be related with graph. Okay, so I'm using one library. Okay? This is a library in the I think it is in the Anaconda. Okay, if you don't have this library, you can try to install it in your Anaconda. And I give this code. If you want to run your code into one file, okay, so I give you this code. So if you are if you want to try this one, for example, I'm making the random graph GNM. It is just a graph random generator. And let's suppose I want to create the number of nodes equals to 10 and the number of edges equal to 30. Okay. So in this case, I'm going to make a random graph n comma m. Okay. So this n comma m indicates the 10 nodes and 30 edges. And let's do the iteration. Okay. So with this random generator, I can write something. Okay. If you're doing with the, let's suppose, yeah, you said that, okay, I want to use another kind of algorithms. I'm not going to use the DFS and BFS. I'm going to use like the Floyd-Warshall, or I'm going to use the A star algorithm and etc. Okay, so I think I could suggest you to create something like this one. So this way is to create a new file, which is test list. W means I want to write. Okay? I want to write into a file. And then for every edges, I'm generating from the graph dot edges, it will be written like this way. So if you go to your file and you can go to the left panel, you can find one file which is test.edgelist. If you open this one, okay, you can find this kind of way. So this is the generated file from this code. Okay, so I'm going to make the g1.add 0. So it is the information that you are going to put from the ads. In this case, I'm going to include 0, 5, 0, 1, 0, 9. So it is a combination between two nodes. And you want to add all those nodes into the G1 or graph 1, for example. Yeah, you can modify this one. And after you have this code, then you want to add into your Python file. That's fine. So let's suppose I don't want to use this file, but I would like to use only the Python code. So I have node 10 and I have the ads 30, and let me generate a random number, and I would like to put it into a list. Okay, you know, list, it is an empty list. Okay, LL is an empty list, and I want to put every ads into that list. So if I run this, yeah, I'm going to generate a graph, and as you know from the first example, the graph is using a tuple. Okay, do you know what is the difference between list and tuple? So list is a data structure in Python that is available for modification. Okay, but the tuple is immutable. It means the data cannot be changed when you already have those kind of array. So I'm going to use tuple to convert the LL. The LL means this is the list of the data that you created, and I'm going to make it as a tuple. So using this tuple function, I generated a new tuple, and yes, this is the information. Okay, this is from the random data. So this is a list of ads, another ads, another ads, another ads, and so on. And after you have these ads, I want to create a new graph. Okay, you know from the graph from ads list in the first part, if I give data of ads, then I will make a new graph. Okay, so this true means, yeah, this is a graph for the directed graph. Okay, let's suppose I'm using this directed graph. Okay. You can check from the chapter 3, and chapter 3, yeah, I guess it's chapter 3. We learn about how can we calculate the runtime of an algorithm. Okay, I would like to review a little bit about this one. So if you do the runtime performance, you want to get the starting time. So the starting time is the current time before you run the algorithm. And after you run the algorithm, you will plot the end time. Okay? And check the elapsed time. The elapsed time will be the end time minus the start time. So I hope we can get, yeah, the time performance of the respective algorithm. So we are going to calculate this one, but before we do this one, let's generate more random number. Let's suppose I have the second random number, and the number of nodes equals to 100 and the edges is 300. Okay, the idea is the same with the previous one. So I guess you can just follow this one. I'm making the LL 100 to make it as a list of information, and then I will put all the ads into this list, and I'm making the tuple. After I'm making the tuple, I put the graph into the graph random 02. Okay, so this is the graph random 02, and I will also do the same thing for the next random generator. I'm making nodes equals to 1000 and the edges equal to 3000. I don't want to print all those information because it will be very long, and yeah, the number of Jupyter notebook line will be very long. So I guess you can just check from this random 01. This is the random 01. Okay. So let me make the random 03. Okay, so if let's say I have this 01, 02, 03. Okay. And I want to calculate the runtime performance for the DFS. As I mentioned to you, we need to know the function of the DFS. In this case, I'm using the DFS complete. So you already know from the algorithm from the code of DFS, we have one function, DFS complete. And for this DFS complete, it will run your algorithm according to the FN. So let's suppose the FN is the graph that you want to apply. Okay, so when you run the DFS, I want to plot the start time and the end time, and yeah, I want to check how long the algorithm works. So let me run this, and suppose that we want to check the runtime performance of 5 data: the graph Korea, random 1, random 2, random 3, and random 4. And the number of data will increase. So I plot the T1 equals to the runtime for the graph Korea. T2 is the runtime of graph random 01. T3 is the runtime of graph random 02. T4 will be the runtime of graph random 03. And if you check this one, okay, it is like 0.00 something 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 second. Okay, so this is in second. And maybe this is very small. Okay, it's not that meaningful, but okay, let's make one more data. So I'm making the node equals to 10,000 and the edges equal to 30,000. Okay, so I think this is the same with the previous example. We are just making a new random graph, which is graph random 04. And let's do the runtime. Let's check. Oh, okay, 0.08. So yeah, it increased. Okay, let me keep this one and let's use the list. For example, I use the list name test DFS, and the test DFS is an empty list, and then I want to append T1, T2, T3, T4, T5. Okay, so those numbers are the time that has been added into a list. And for the second time, I would like to test the runtime performance of BFS. Okay, I want to compare the DFS and BFS. I want to compare the performance of DFS and BFS. So we also need to check the runtime performance of BFS. Let me just make a new runtime. Okay. Oh, yeah, you can modify the function. Okay. In this case, I'm overlapping the previous function, but you can change later. Let me just use this one, and then I'm generating the runtime from the BFS. Yeah, I'm using the BFS, and then this is the random 1, random 2, random 3, random 4, and then let's just add those number into this list. That's BFS. Okay, now I already have the list. That's BFS, and then I append the S1, S2, S3, S4, S5, and S1, S2, S3, S4 is from this runtime performance. After you get those numbers, now we are going to plot. Okay, how can we plot? So the first time before you plot, let's check the plot using the X and Y. Okay, the X in this case, I'm considering the number of nodes, not the number of edges. Okay, you can change later if you want to consider the number of edges. That yeah, you can add also. But for this, I'm using the number of nodes like 5, 10, 100, 10, 1000, and 10,000. And then I'm going to check the test DFS. Okay, let's see. Yep, this is the number of data. We have 1, 2, 3, 4, 5. And once you check the time performance of the first, the second, and the third is very small. Okay, yeah, it is like you cannot see. It's very small, 0.00 something. So that's why Python just give you the 0.0. But it's slightly increased when you use the number of nodes 1000, and yeah, it goes up when the number of nodes is 10,000. So for this purpose, we can use the matplotlib. This is one of the library in Python, and you can use this matplotlib like this way. You can just matplotlib inline, and then you can import the matplotlib with this pyplot splt, and then you can just import the pylab, and the x label will be the number of data, and then the y label will be the time, and you will plot the DFS. Let's say this is the DFS, and yeah, the plot will be x comma y. So the RO means the type of the graph. Okay, so RO dash, so it means the type of this line. So if you run this, yeah, oops, sorry, I guess I need to run this one. Yeah, I need to run this X. Yeah, you can check this DFS, and then yeah. Now you can get, this is the plot of the time performance in the respective of the DFS algorithm. Now you want to check the BFS as well. How can you know whether DFS is better or BFS? Then yeah, I would like to put those two into one graph. So the same with the previous, the X will be the number of data, the Y label will be the time. And now I would like to compare the DFS and BFS. So the test will be something like this one. The DFS will be written in the RO dash, and the color will be red. And the test BFS will be also the same dash, but yeah, it will be written in the blue color. And then I would like to give the legend DFS BFS. It means this one, this legend, and the location is upper left. And then show it. Oh, okay. It's a little bit different with the previous one because it's randomly generated. Okay. So in this case, what can I say? It seems that the BFS is slightly higher. Okay. Okay. So you can see the first time the DFS is higher than the BFS, but at the end the BFS is slightly higher. Okay. Yeah. This kind of performance can be different with your performance, especially when it depends on your laptop or it depends on your desktop. So when you're using different tools or different device, this information also different. So make sure that you include the information of your computer. For example, yeah, you can express I'm using laptop with the specification. I'm not sure what is your computer. For example, i5, and yeah, maybe you also explain the memory with 16 gigabyte RAM. Okay, so this kind of information is also important because different computer will give you different results. So that's why in our data structure and algorithms, big O is important because we cannot make sure that this result will be the same when you run in different computers. So big O will be very important to note that which algorithm is the best one. From the big O perspective, BFS and DFS is not a big difference. So that's why this kind of graph will show you that yeah, it has a slightly different according to the time performance. Is the thing we need to consider for this kind of analysis. So yeah, I guess that's all for this explanation. I hope that it will help you to figure out how can you perform your algorithm for the team project. Okay, so using this kind of idea, you can try to plot your time performance. And I don't know what are you going to use in your team project, but at least this kind of idea will be very helpful for you to show the result of your algorithm. Okay, then thank you very much for listening and see you on the next video.